All right, welcome back, everyone. Now we're going to start discussing spanning tree protocol. Okay. Now the nature of switches is not, again, these are labs. It's not meant to be a concepts class, but either way, uh, the nature of switches is to forward their frames, right? Their bridge protocol data units, right? BPDUs, constantly over and over and over and over and over again. So uh, when you have redundant link like these, like again, the nature of switches is to forward ports. It would constantly be going round and round and round and round and round and round and round, causing something that we really don't want, which is a broadcast storm. Therefore, SpanningTree watches these ports and says, okay, I'm going to go ahead and block a port so that port will not forward no longer. So as you can see the amber light there, that means that port has been blocked. Okay, and let's take a look at that. So I'm going to go inside that switch. And now let's call this switch 2. So we know the switches that we're working on. This is switch 2. I know I went to it first, but I want to call it switch 2. Okay. Again, caps slash host name SW2. All right, the command that we want to do, we do it from privilege mode. Control Z. All right, and I'm just going to copy that. Control Shift 6. See, didn't know, hey, I need to look for a domain name server to see what the heck is WRE. All right, so WR. So that's why we do no IP domain lookup, so that doesn't happen. Anyway, show spanning tree. All right, and I tabbed it out, I know. All right, so I hit enter. And we take a look at this information right here. This information tells you about the root bridge, and this information tells you about the switch itself. And then down here, you're looking at the ports, right? And it's telling you, hey, what's a root port and what's an alternating block port, a root forwarding alternating block. The cost, this was given to Ethernet as the cost of 19. All right, don't worry about it. Just know that that's the cost of fast Ethernet. Okay, gigabit is 4. I think Ethernet is if fast Ethernet is 19. I think Ethernet, which is slower, it's a little bit higher cost. I don't remember the number. It doesn't really matter. Anyway, so what are we looking at? The default priority number is 32769. All right, for the root bridge, and the default priority number for this switch in particular is 32769 as well. So why did I block a port here? Because it's using the MAC address. All right, you take a look at the MAC address of the root bridge, which is this one up here. It's 0001, where this switch that we're in is 00D. Oh, this is higher. It's a higher MAC address. Therefore, it chose it based on MAC address and solely that MAC address information. All right. Now, that's why it chose to block a port. But hey, Laz, why did it block port 4 and not port 2? Because it will look at the higher port number, because the higher port number has what? A higher MAC address. A higher MAC address. If you look at that, show interface F0/4, and we see the MAC address is here 006, blah, 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 blah. Okay. Now let's take a look at F02. All right, and we go up. Let's see if we can do it here. Here's the F02 port, 5C02. This is 5C04. Everything else is the same. So the Fast Ethernet 4 is a higher MAC address. Therefore, it chose that. So the switch was chosen because the switch itself has a higher MAC address, and then to block a port, and then it chose the port to block based on the higher port number in this situation. And you see the other one is root, because all ports facing the root bridge must be root ports. Alas, you just said that the other port is blocked and it's facing the root bridge. Well, here it has to block a port, right? It has no choice. So it's got to pick a port, or else we're going to have a broadcast storm. So it picked 4. Now let's take a look at the other switch. Let's name that one switch 1. Enable, config T, host name, SW1. All right. Do WR. Let's do Control Z here. And let's do show spanning tree. All right. You can see it even tells you, hey, this is the root bridge. And you can see they both have identical priorities, bridge priority numbers, right? Same. What changes is the actual MAC address. So lower MAC address, this is root port. And look at this. All ports on the root bridge will be designated forwarding. Designated forwarding. Now I'm going to repeat something that I've been repeating all along. You are taking a CCNA certification. You are not taking a particular certification for a vendor. It's not what you do at your job. It's not the CCNP or the CCIE. This is the CCNA. Therefore, to change who you want to be the spanning tree, or who you want to be the root bridge, or changing bridge priorities and all that, this is the way you would do it. And these are the commands that you would use when looking at SpanningTree, when doing it for the CCNA certification. Okay? Keep that in mind. You're taking a test, ladies and gentlemen. Okay? So we know that based on the MAC address, this became the root bridge, and it says it right there. And there's no block ports. Okay, so what we're going to do is we're going to fix this election, and we're going to make this guy the root bridge. Okay, so how do we do that? Well, we change the bridge priority. Okay, so how do we do that? Let's go ahead and do it. We have in global configuration, and we're going to go spanning tree VLAN 1, because that's the only VLAN we have. Priority. Now I'm going to type a mistake on purpose. I'm going to put 6. It says, hey, you can't do that. We increment by 4096 and we start at 0. And then these are the values that are allowed, right? So starting from 0, and then these are the values that we can use. Okay, cool. But I want you to take a look at this number real quick, okay? 32768. Take a look at that number. All right, I'm going to up arrow, and I'm going to put 0 because I want this guy to always be the root bridge. And then I'll come back to that number in a bit. All right, and you can see that the lights turned amber. SpanningTree is going crazy. It's saying, oh my God, I got to recalculate everything now. All right, they changed my bridge priority, and that is the main thing that I first look at when I start making this election process. So obviously it takes forever for it to do that, but let's see what happens. All right, I can guarantee you that port 3 is going to stay amber, and port 2 and 4 are going to turn green. Because now he's the root bridge. It takes a bit. It's not the most speediest protocol in the world. And in the packet tracer, even longer. Okay? So let's just wait a little bit more here. Come on now. Well, let's see if it already says it, even though this is amber. Let's see if it says it already. Oh, there it goes. It turned green. You got scared of me. Alright, so I'm going to do a do WR. I'm going to do show. Oh no, if I do it from here, I got to type it out. It's not going to have it. Show spanning tree. Hey, now this guy's the root bridge. Look at that, because this priority is 1. I thought we put 0. Didn't we put 0? We sure did. But look, the priority is set to 0, but it adds a 1 to it because of VLAN 1. All right, but you can see now the ports are designated forwarding. All right, but keep that in mind. You see we put 0, but it's adding 1 for VLAN 1, right? Remember this number I told you to keep in your head? Where is it? Did I pass it already? No, maybe so. All right, whatever. All right, so we go here. I said 32768. Keep that number in your head. And you can see that this port is blocked. Higher MAC address. All right. So let's do the span tree again. The command, because we refresh that. He's no longer the root bridge. The root bridge, priority of 1. Look at that. The MAC address is the one with a higher MAC address. This has a lower MAC address. Remember I told you keep in mind 32768? But it adds a 1 because of VLAN 1 and therefore making it 32769. That's when they ask you questions in your exam. Hey, what is the default bridge priority number? 32769. That's what you say. But it's 32769 because it got added a number 1 for VLAN 1 to this number. Because if you looked at the priority numbers, right? Remember when we typed spanning tree? Well, never mind, not there. Config T. Spanning tree, VLAN 1, priority, and I just typed a random number. It said no, you can't do it. See, 32,768. There's no 32,769 in here. So 32,768. That's where it gets this and adds VLAN 1 to it, and that becomes 32,769. All right, but that's how you can manipulate spanning tree. Okay, in this situation, 2 switches, right? 2 switches, fairly simple. Okay, not a big deal. Same concept though, but now we have 3 switches. So obviously by looking at the lights here, we can tell, all right, well, we know that this amber light here, all right, and this switch is blocked. So definitely that is not going to be the root bridge. And then I said all ports facing the root bridge must be a forwarding port. Well, obviously this is a block port. It's facing this guy. So he's not the root bridge. It must be him. Because he's green and facing him. He's green and facing him. So this guy must be, switch number 3, must be the root bridge. Let's open this up here so we can take a look at it. Nice and big. There we go. Enable. And let's give it a name. Let's give it the name that it has. Config T. Host name. SW3. Alright. Do WR. Oops. And let's do a Control Z. Show. Because the only reason I do a Control Z because I don't want to type out SpanningTree. For some reason, my fingers don't want to go that way. Alright, and you can see that this is the root bridge. It's telling you right here. It's the root bridge, and they're all designated forwarding ports. And if you look at it, the priorities are the same. Alright, and this switch, obviously, look at the MAC address of the root bridge. It's that. MAC address, obviously, is going to be the same. So let's take a look at the others. Let's go to this switch right here, switch 4. Again, let's open this up here so you can see it nice and clear. I'm going to go to switch 4. Let's name it first so we know where we're in. Config T, host name, SW4, enter, do WR, Control Z, show spanning tree, not SOPA. Okay, so here's the information. This, remember, is information about the root bridge. 0030, right, was the MAC address. Well, he's 0032. Okay, didn't choose that. Well, let's go to the second one. A3E7. Oh, this is F. So this is a higher MAC address because this is A. So this is F. So this is why this guy could not be a root bridge. But his ports, one's a designated port and one's a root port. This is key to know because root ports always face the root bridge. The root bridge. Okay, so keep that in mind. Keep that in mind. All right, and then the designated port is port 23. Okay, so no block ports there. Let's take a look at the top switch, which is switch. I think this, what switch would this be? Switch 2. Okay, switch 2. Yeah, I'm moving around a little bit so you can see what's going on. Let's bring this up here. And let's open her up a little bit here. There we go. So we're in switch 2. Let's name it. Config T. Host name. SW2. Excuse me. Let's do Control Z. Show spanning tree. And we can see again information about the root bridge. We know that MAC address, right? But look at our MAC address is 009. The other switch, switch 4, was 003. You had to go into here to find the F, and this was an A, so that's why. But here, right in the beginning, it has a higher MAC address than all of them. So it became the port or the switch where SpanningTree said, okay, I'm going to like you to block a port on. I'm going to choose you because you have the higher MAC address on the switch, and then I'm going to block one of your ports. And it chose, in this case, the higher port once again because it's a higher MAC address. right? It's the higher MAC address. And it's not, the other port is facing the root bridge, which is port 22. And here it is, port 22 facing the root bridge. I'm not facing the root bridge, so I can go ahead and block this port. That was a decision that was made. Well, he's facing the root bridge, so therefore I can't block that port. Oh, well, this guy's not facing the root bridge. I'm going to block this port again, but it's a higher MAC address. But watch what happens. Watch what happens. These are higher port numbers up here, aren't they not? Then these two, they're both really the same, 21 and 21. Let's see what's going to happen. I'm going to make the top bridge or switch the root bridge. So I'm going to go SpanningTree, VLAN 1, priority 0, enter, UWR. So let's take a look at the colored lights. Right, so we have 2 amber lights, one here, one here. And we just got to wait for SpanningTree to do its thing, but I guarantee you that this is going to stay amber. Because if this is the root bridge, all ports facing the root bridge must be root ports. All right, you see this is green. There you go. There's your switch. There's your root bridge right here. These are your root ports. Look at that. The lower port number, even though it has a lower MAC address. But it says, hey, this guy's not facing the root bridge, so we're going to block that port. All right, because remember, this did have a higher MAC address than this guy, right? This has an F where this had a D in the second, an A in the second octet, in the second section. So let's take a look. And we'll do Control Z, show SpanningTree. And there we go, priority of 1, which is really 0, but we know now that it adds for VLAN 1. And you see that this is the root bridge. And they're all designated forwarding ports. Once again, all ports in the root bridge must be designated forwarding. Okay? And then we come down to this guy, which are all designated forwarding ports. Well, not really. It has one root bridge, sorry. One root bridge. Sorry about that. One root port and one designated forwarding port. The root port means that it's facing the root bridge. All right. And then, and we look at the MAC address of the switch. You see, it was an A. Remember, this used to be the root bridge. It was an A. It has the lowest MAC address of all 3. And then we come over here, and we do show SpanningTree over here. Now this has a root port, which is the higher port number because it's facing the root bridge. And the lower port number is alternating block. And that reason for that is that it's not facing the root bridge. That was the decision process right there. That's how I made that port to be blocked. So this is what you do. One of the things when you're doing your certification, the first thing you need to pick out is who is going to be my root bridge. And you're going to look at either bridge priority or the MAC address to decide, because the root bridge, that way you know your ports, designated. Facing the root bridge, root port. Not facing, designated forwarding, and then block port based on a higher MAC address of the switch in this case. All right, that is SpanningTree. Not such a big deal. Okay, that is SpanningTree. And one more thing, just to throw it in there. If you're on a switch, okay, let's pick this switch right here, the one that's blocked. One command that's very helpful: show CDP neighbor, right? So Cisco proprietary protocol, Cisco discovery protocol, to look at your neighbors. I say, okay, why is this so important? It's the root port. Well, you need to know that because this root port, okay, is facing the root bridge. What port is that? My local F023. Well, here's my F023. Oh, okay, my F023 is pointing to switch 2. So if you were to be asked, hey, what's the name of the root bridge or what have you, you take a look, and you're stuck on a switch like this one, you can say, well, show CDP neighbor. or you do show spanning tree first, obviously, and you see, okay, well, here's my root port. All right, my root port faces the root bridge is port 23. Here's port 23, and port 23 is looking at switch number 2. So, whatever name they gave it, but that's what it is. All right. So show CDP neighbor and also show CDP neighbor detail, but we have no IP addresses. So that's the only reason you put the detail is to look at the layer 3 information. So that's SpanningTree in a nutshell. Well, that's it. Very simple, very straightforward. Okay, it's not that hard. Okay, you guys can do this. All right. In our next lecture, we're gonna start securing some ports. All right, we'll do securing ports in a different, similar but different type of topology. I'll see you then.